Calculus 1. Actually, we are moving to section 2.3, some further discussions of limit laws. And I hope you remember, so far we covered two ways to find our limit. We are going to use a graph, and also we can use table values to find our limit. But anyway, I really want you to know there are issues with those two approaches. And many times, given a function, usually it is very hard to get the graph. So it is not very reliable. And also there are issues with the table too. And believe it or not, because we are doing this entire thing online, so I'm not going to give any specific examples. But anyway, I just want you to know, using table to find our limit, still it is not reliable. So we really need to find out some efficient and better ways to find the limits. So we are moving to section 2.3, limit laws. The first way, it is really all about direct substitution. Remember, in chapter 1, somewhat we consider functions in different ways. There are different ways to name the functions, and to some of us that might be a new term. We have functions. They are considered as power functions. Okay, so in this case, I just want you to know the limit of power function. It can be found always directly by plugging the value. Replace x with the value. Okay, and also we do have some rules for the limit of a function and limit of sum. So limit of sum would be the sum of two limits. Limit of difference, very similar way. It is difference of two limits. Limit of product, it is product of two limits. Limit of quotient is the quotient of two limits. And using those rules, basically it does allow us to do some very simple calculation to find our limit. So for example, this is 2.14 from the textbook. To find out the limit as x approaching to -3, honestly, I just want you to know we really don't bother about -3.1, -2.9, those things. We simply plug in value. So 4 times -3 plus 2, which is -10. That is the limit. Okay. Another example from the textbook, it may look a little more complicated, but you really don't have to think too much. If it's all possible, you just plug in value. Replace x with that given value. And indeed, it works perfectly fine. I think in the end, you simplify the answer, it is 1/4. It is 1/4. Okay. And one more example, it has radicals. You may wonder what would happen to radicals. Basically, this is a polynomial, this is a rational, then it's a function with radicals. We do the same. The rule is, if all possible, you just plug in value. That is the so-called direct substitution. So this is still the one from the textbook. Checkpoint 2.11, find our limit as x approaching to 6. I really did not consider too much. I did not bother with the graph, or really I did not bother with the table. And besides, you really want to know the graph and the table, they are really not reliable. Okay, so I did the direct substitution, replace x with 6. So the limit, it is 11 times square root of 10. This is indeed, it is the perfect limit. It is the correct limit. This is really indeed the best way to find out the limit. And indeed, we are going to do a little more about limits. There are different ways, different techniques, or different tricks. But anyway, in the end, the only way to find a limit, it is doing the direct substitution. Thank you for watching.